Hello everyone and welcome back to Algebra 2. Today we're going to be talking about 1-6 absolute value of equations and inequalities. Let's get started. So, first things first, let's do a little bit of review on vocab. We must circle the solution of 3x plus 8 equals negative 4. So we have a 3x plus 8 equals a negative 4. I'm going to subtract the 8 to the other side because, again, we're trying to get the x by itself. So we now have a 3x is going to equal a negative 12. We are then going to divide both sides by 3. We're moving everything away from that x, and we're going to be left with x is going to equal a negative 4. So your first answer should be x equals a negative 4. There we go. And today we're going to talk about the absolute value. We did have a brief little bit about the absolute value. The fact that the absolute value is a distance, and that is a very, very important thing. Distance from 0. So distance is basically saying that it cannot be negative. Notice the distance from a negative 2 is going to be 2 units to get to that 0. The distance from the positive 2 is once again 2 full units to get to that 0 as well. Therefore, since negative 2 and 2 are 2 units from 0, the absolute value of negative 2 as well as the absolute value of 2 will also be a positive 2. Alright, so no matter what, it will always stay positive. So, can we graph each absolute value of the number on the number line? First things first, what is the absolute value of 3? Absolute value of 3 is a positive 3. So I'm going to put a dot at the positive 3. And I'm going to label that as the absolute value of 3. The absolute value of negative 2 should be 2. So again, I'm going to put that, even though it is a negative 2, I'm going to put that on the positive 2 up here. A negative absolute value of 1. Now, the negative is not in the inside of the absolute value. Therefore, we are going to figure out the absolute value of 1, which is 1, and then we're going to actually multiply it by the negative. You can picture an absolute value as basically their own set of parentheses. It's their own special parenthesis where it forces everything on the inside to become positive. So we do have a 1. We are going to multiply it by negative 1, which means that it's going to be a negative 1. So a negative absolute value of 1 should be at the negative 1 spot. So last but not least, you have the absolute value of negative 2, which is 2. But again, like I said, the absolute values kind of work like parentheses. So we have 2 times 2 now, which is 4. So I'm going to put that last dot right here. So this should be the 2 absolute value of that negative 2. And that's exactly where I'll put it. Alright. Now, complete each graph. If I had to complete this graph, I'm going to have the absolute value of x equals 4. That means that we could have 2 different values for that x, right? Because like we said before, as long as this answer is positive, we can plug in 2 different numbers for that x. We can have the negative 4 being the absolute value sign, and we could have the positive 4 being the absolute value sign. So that x could actually be negative 4 and positive 4. And the same thing goes for the 5. Instead of it being just at the 5, which is right here, we can also have it be at the negative 5 because the absolute value of negative 5 will also work for this problem. Now, using that idea, what is the solution of the absolute value of 3x plus 2 equals 4? And then we have to graph the solution. So we have to write it as 2 equations because, like we said, you can have the negative version as well as the positive version. So what we need to make sure is whatever is on the inside of the absolute value has to equal a positive 4, or it could possibly equal a negative 4. So my 2 equations that I'm going to have will be what's inside the absolute value, that 3x plus 2, and it's going to equal a positive 4. But then we're also going to rewrite it as 3x plus 2 equals a negative 4. Again, if whatever's inside the absolute value equals the negative 4, the absolute value of a negative 4 will still equal that 4. So we must have the negative version as well. Complete the steps to find the x. Well, it's the same exact way both ways. So the very first one, we have a 3x plus 2 equals 4. The next step will be to subtract out the 2's. And then last but not least, we're going to divide everything by 3. And when you get that, it'll become x equals 2 over 3. And I wrote it up so you can see it a little bit nicer. The next one, rewrite the equation right here. We're going to bring that straight down. You have to subtract 2 from each side. Perfect. So minus 2, minus 2. When you do that, you'll get a 3x equals a negative 6, just like this middle part says. Divide each side by 3. So I'm going to divide each side by 3. And I'll show it as well. And sure enough, negative 6 divided by 3 gives you at negative 2. Now, where would the solutions be? Well, the answer could be either 2/3 or it could be negative 2. So I'm going to go to the negative 2 and I'm going to put a spot or a dot. I'm then going to go to 2/3, which is very, very close to the 1, but not quite there. And I'm going to put a dot. And those are your solutions. What is the solution? 2 times x plus 9 plus 3 equals 7. We need to graph the solution. Well, in order for us to go about solving this, we need to make sure we have the absolute values by themselves in order for us to actually set them equal to the negative counterpart. I'm going to subtract the 3 from both sides, like it says over here. If you subtract 3 from 7, you'll get 4. We then have to divide it all out by 2. Again, the absolute values work kind of like parentheses. They're their own special grouping symbol. So if I divide the absolute value by 2, I can cross these out, and we're going to divide that 4 by 2, which is going to give you a 2 as well. So now we have the absolute value of x plus 9 must equal 2. We can start solving it out. So we're going to set it that same equation equal to a positive 2 as well as a negative 2. And then we're going to solve it out the same. So we're going to rewrite it, x plus 9 equals 2. We're then going to have it also rewritten as x plus 9 equals a negative 2. We are going to subtract 9 here. We're going to subtract 9 over here. And you're going to get the two answers, which are x equals a negative 7 and your x equals a negative 11. This number line is a little bit of a mistake on my part. I apologize, because this is going to be the proper number line. It should be going from negative 12 to a positive 12. Alright, so we are going to put a spot at the negative 7, which is in between the negative 8 and the negative 6. And then we're going to put a spot at the negative 11, which is in between the negative 12 and the negative 10. There you go. What is the solution of the absolute value of 5x minus 2 equals 7x plus 14? Well, they're going to say check the extraneous solutions. We need to make sure that these solutions make sense. So they're going to say, hey, after solving the equation, we ended up finding that x equals negative 1 and x equals negative 8. So I'm going to make sure we substitute each value into the original equation just to make sure it makes sense. So I'm going to first start with that negative 8, because we're going to start with the lowest number. So we have 5 times the negative 8 minus 2 equals 7 times, again, the negative 8. The most important part is that we are going to use negative 8 as x in both positions. Now, personally, again, I would prefer you to use parentheses to plug things in, but it should still work either way. So when I plug in that negative 8, you get 5 times a negative 8, which is a negative 40. Negative 40. And then we're going to subtract 2 from that, giving you an absolute value of negative 42. Well, if I come over here and I say we have a negative 8 times 7, you'll get a negative 56. If we add 14 to it, however, we will stick with a negative 42. But this side says the absolute value of negative 42. And absolute value can never be negative. So it doesn't look like this one actually works. Alright, so let's check out the negative 1 just to make sure that we have at least one solution. So 5 times a negative 1, which will give you that negative 5, minus the 2, which will give you a negative 7. And then we also have a 7 times a negative 1 right here, which is going to be negative 7 plus 14. Which will give you a positive 7. So our answer should have the absolute value of negative 7 equals 7. So does the absolute value of negative 7 equal 7? Yes, it does. So which, if any, solutions are extraneous? Meaning which ones don't make any sense? Well, the one solution that was extraneous was the negative 8. Why? Because the absolute value of, and this should have been a negative 42, equals 42, not the negative 42. But again, the negative 1 does work. The negative 1 is the correct answer. This case, negative 8 is not. What is the solution of the absolute value of 3x minus 4 less than or equal to 8? Graph the solution. Well, the inequality is solved below using these justifications to complete each step. Write the compound inequality. We have the positive form of the 8, which is right here, and then to make it the compound inequality, we are going to also add its negative counterpart, which is going to be the negative 8 as well. All right? And that is what we're going to plug in right here, because we're going to take that 3x minus 4 and just drop it straight in out of the absolute value and straight into this inequality. We are going to add 4 to both sides. When I say both sides, I mean all sides. So yes, I added 4 in the middle, but what you do to one side, you technically have to do the other. But if you're doing it to the other, we have to make sure we do it to both sides altogether. So we have the negative 8 plus 4, which gives you negative 4. We're going to bring down that 3x because that's what's left over. This cancels out. And then you have 8 plus 4, which is 12. Now, just like we did before with the adding 4 to every spot, we're going to divide by 3 to each position. When you divide by 3, you'll get a negative 4 over 3 is going to be less than or equal to the x, which is less than or equal to 12 divided by 3, which is 4. So the endpoints of the graph are going to be the lowest number and the highest number. So it's going to be the negative 4/3 and the 4. The endpoints are going to be indicated with a closed dot. And the reason it's going to be closed is because of the fact that it's going to be the equal to portion, right? So it's going to be less than or equal to. The less than or equal to. So now we just have to graph it, which means we're going to go to negative 4 over 3, which is going to be somewhere in this range. I believe somewhere around there. So I'm going to put negative 4 over 3. And then over here, we're going to go to the 4th spot. And we're talking about everything in between, so I'm going to be putting a line from the negative 4/3 all the way up to the positive 4. And that's exactly what is shown. One last little bit. Since we're taking the absolute value of the less than sign, which is what this entire slide is about, that is why you write it as a compound inequality, where it's talking about in between numbers. So it starts from the lowest number is less than or equal to the expression that we're talking about that is inside the absolute value, which is also then less than or equal to the highest number. The reason I say that is because when you talk about greater than or equal to, you run into this problem. If the number in the absolute value has to be greater than a number, we have to write it as an OR statement, where we're going to have one inequality where whatever is inside the absolute value has to be less than the opposite counterpart to the 15 that is given, or it needs to be exactly as we see it without the absolute value. So again, 5x plus 10, or everything that's inside the absolute value, has to be less than the negative counterpart, so the 15 became a negative 15, or the 5x plus 10, which is everything inside the absolute value, has to be greater than 15, which is basically the original inequality minus the absolute value signs that we see. You solve it for x the same exact way, though. So we'll get 5x plus 10 has to be less than negative 15. I'm going to subtract 10 from both sides. You'll get a 5x. It has to be less than a negative 25. Divide by 5. And you'll get that x has to be less than a negative 5. Now, again, we're not dividing by a negative number. We're not multiplying by a negative number. We're dividing from a negative number, which means we do not have to worry about changing the signs. But if I wanted to go ahead and immediately plot this on the graph, I can. All right, so x has to be less than -5. So I'm going to go to -5. I'm going to make an open circle because it's less than, and it's not closed because it's not less than or equal to. And I'm going to be going to point my arrow into the numbers that happen to be less than that -5. And then we have to use the same exact method over here by bringing down what we have, and we have a 5x plus 10 has to be greater than 15. Alright, subtract the 10 to both sides. 5x is greater than 15 minus 10, which is 5. We're going to then divide everything by 5. And you'll get x has to be greater than 5 divided by 5, which is 1. Which we're going to go down into the graph. It's greater than, not greater than or equal to, so I'm going to make it an open circle on the where I think the 1 roughly is, and then I'm going to talk about all the numbers larger than 1. So I'm going to point that one off to the side. So just to reiterate this one more time, if you have an inequality that happens to be greater than the absolute value, you are going to take whatever's on the inside of the absolute value and rewrite it greater than to whatever the number that we're talking about. So that's why you had the 5x plus 10 is greater than 15. And then you're going to take the whatever's inside the absolute value once more and set it less than the negative counterpart to that 15. So that would be the 5x plus 10 is less than the negative 15. Remember, there is a difference between the less than version of an absolute value inequality and the greater than version of the absolute value inequality. Suppose the smallest allowable height for a race car is 52 inches, and the desirable height is 52.5 inches. What absolute value inequality describes height of a race car within an indicated tolerance? Find the difference between the desirable height and the smallest allowable height. Well, the difference between that two would be 52.5 minus 52. And if you do 52.5 minus 52, you'll get 0.5. So circle the expression that models the difference between the desirable height and the actual height. Well, the desirable height will be the 52.5 minus whatever our original height is, which is the h. Will happen to be right here. Write the compound inequality. If we already circled the expression that models the difference between the desirable height and the actual height, we can throw this expression into this compound inequality, and you'll end up with a negative 0.5, which is less than or equal to a 52.5 minus h, which is less than or equal to 0.5. And then how would you go about rewriting the inequality as an absolute value? Well, since it's all working in the same direction, it's always less than or equal to, less than or equal to, we always have to make sure that we follow the positive because we are working with the absolute value. So the absolute value must be less than or equal to a 0.5. But I'm just going to rewrite what's inside the compound inequality in the middle, that 52.5 minus h, inside the absolute value. And then I'm going to make sure I keep the positive form for what the less than or equal to is going to be attached with. So it should be a 0.5. And finally, we made it to the lesson check, which means we are basically done. So let's go through this really quick. When is the absolute value of a number equal to itself? Well, the absolute value of 0 is equal to 0. Again, it can't be negative, can't be positive. So if I wanted to know the distance from 0 to 0, we don't have to go anywhere. So it's 0. When a number is negative, its absolute value is equal to its opposite. In other words, the positive. And I want to stray away from using the word opposite. Since it is distance, it is the positive form. And the reason I say stay away from its opposite is because when a number is positive, its absolute value is equal to itself. All right? It's going to stay positive. Using the word opposite is one of the major problems that people run into. If I say like the absolute value of 3, a lot of people might say negative 3 because they're thinking about it being its opposite. and that is not correct. So make sure you pay attention to it as it's positive. It always turns it positive, and it keeps positives positive. So, answer the question. The absolute value of a number is equal to itself when it is 0 or positive. And again, you have to reiterate the 0 part because 0 is neither positive nor is it negative. And that's it, everybody. We made it through all 30 questions. Congratulations. Thank you so much for joining me. I hope you have a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you in the next one.